Wait, we gotta look at more information.
10% tax, 10% discount. So use the numbers, work through that. Does this matter? It seems like, based on these friendly numbers we've used, that it doesn't make a difference based on what we've done. And some people have gone on and beyond that, and that's awesome. And that's what kids are going to do as well, because you want to know, right? So if we do the discount first, and I had an argument in my head about which one this was, what we're doing is the $100, that's the cost, and we have to know how to find what that discount, and we have to know that you're taking the discount away from the total cost. So the discount would be $100. I'm sorry, the cost is $100, and to find the discount, I'm going to multiply that by the 10% in decimal form would be 0.110, and that is $10. So that's the $10 discount. Okay, and then we take that away from the $100, and we get $90 as that discounted price. Then we need to figure out the tax, because that gets added onto the discounted price. So the tax is going to be that $90 cost times the 10%, and that gives you the tax of $9, which you add on to that discounted price, and so you're going to pay $99 for that item. Okay, so that's discount first, which is what she wanted. The other way would be the tax first, which would be that $100 times the 10%, which would be $11. So that's what Jeannie was saying about the state wanting more. Oh no. Okay. I was right, wasn't I? Okay. Okay, it would be $110, and then subtracting the discount after the tax, which would be $11, and you get $99 either way. Yeah? Okay, so our math is now correct on that. The calculation is. And it was nice to work together to kind of verify that, or
So I just need to say, it doesn't matter to you as the consumer.
right. In this instance.
Right. If you were the tax collector, it makes a difference.
Absolutely. Yeah. Question, just for clarification, because this gets into a whole nother side part, is does it matter to the consumer? So yes, it matters, but now we're talking about does it matter to the consumer? So you've done some work. You have an explanation. Are you happy with the explanation or the justification you have? Do you think it's really sound and it's going to hold up with any number, any situation? Okay. So what you're going to do is work with your partner. So partners are going to work together and work through different situations, try some different numbers, and I would like you to construct your conjecture, so your opinion, and your explanation on that whiteboard, so numbers and words. Okay, use the information with your partners.
Yeah.
Okay, and now I'm going to give you some information that might help you make sense of what you're already thinking. Okay? So in this type of teaching, and it might help you with these mathematical reasonings that are so crucial in making these justifications, because the best justification has sound mathematical reasoning. So I'm going to now explain some things to you. So sometimes in teaching, don't don't worry, it's not all about I'm not going to ever tell them, I'm not going to ever give them information. They're just going to muddle through and then poof, it's going to come into their brains. Got it? Right? No. Okay. So at this point, this is when the teacher is going to come through and give you some information to help you make your justification. So let's look at what we've been doing. And in my original thought and what I would do with kids is kind of think through this as I'm putting this up here. But this is too complex for me to think through this verbally, so I put it all up here first. So just so you know, I'm struggling with this as well. Okay, so the real question we're really focusing on is it doesn't seem to matter if we do the cost with the tax, then subtract the discount. Or if we do the cost, subtract the discount, and then add the tax. We seem to get that same answer. So we're going to look over here first and just look at this concept of figuring out this discount price. Okay? These two things are the discount price only, just that one part of the problem. Okay? And I know there's some people that are really understanding this, so if I get lost, please help me. Okay, so we're going to look at this with some friendly numbers, not as friendly as 100, 10, and 10, but just a different one, because it makes sense if we want to see if it works with any number to try some other numbers, which you're all doing. So we're going to say the cost of the item is $40, the tax is 25%, and the discount's 25%. So the process to figure this out would be the cost of the item times 25%, you get $10. Okay? So then we take that $10 and we do the cost of the item again. So we did the cost of the item here. We're doing the cost of the item again, a second time. The cost of the item, subtract the $10, and you get $30. Yeah? Okay. So I'm going to take this to another step where we're going to pull some ideas out here and combine them. So if we look at what I wrote here, do some colors. So this $40 is the cost of the item. We did it one time here. We did it 2 times here. So in our whole problem, how many times have we done the cost of the item? Twice. Okay. So now I'm going to take these 2 separate problems that I did, and I'm going to put it together in one equation. Okay? So here's the cost of the item. Yes. So thank you. The cost of the item, subtract, and then instead of subtracting this $10, can I substitute this for this right here? Yes. Thank you for giving me that permission. And I can, because mathematically that works. Yeah? So I'm taking this term, and instead of the $10, I'm going to put that right here. Okay? So we have the cost of the item, and we have the discount here. Okay, and then that equals $30. Okay, so now, okay, so I have this. What is there anything repeated in here? Or can anyone see what I did here? 40, right? We have a 40, and we have a 40. So in this next step, I'm pulling this 40 out and only doing it one time. I can do that because 40 times 1 is 40, right? So if I pull that 40 out, if I take 40 times 1, and if I divide that by 40, I get 1, right? So here's 40 times 1, subtracting 25%.
Yes.
Okay. Then I'm going to simplify this, because I have an operation in here. I'm going to simplify this and say this can really be simplified to say 40 times 75%. And that gives me the discount price. Followed? Okay, good. So a reason why we did this is because in mathematics, and when I was doing this with math teachers, somebody automatically did this and I didn't understand where they got this from. So the reason we want to do this in math, and people that are really great with math, they just do that intuitively, is an important part about math is we want to find the most efficient way to represent something mathematically. So with all of us in our thinking where we are, this is what we had to do to get to this information. But a mathematician would go all the way to here. So I'm giving you this information now to help you with your explanation. But wait, there's more. So that's the discount price, which is, remember, one part of this question. The other part is that tax price, right? Or what we do with this tax, right? Okay. So here's a slide that explains how an efficient way to find the tax. So we're doing the same numbers. So we're looking at 25% times the cost, $40. They just did it a different way, but that doesn't matter. Plus the cost, 1 times 40, right? Okay, so then they factored out, they pulled out that 40, and does anybody know what that property is called? Distributive property, right. If I did it like this, like in the video, right?
You get it now?
You understand? So that's the distributive property. Does anybody know why it's okay? You know, over there I did the cost times the percent first, and here I did percent times cost. Is that a property too?
Commutative.
Commutative.
Yeah.
Thank you. The commutative property. So that means that we can switch the order of numbers in multiplication and addition, and that's okay. The math police won't take this away. It's really that strong mathematical reason. So we have two properties going on here. Okay, so back to here. So we distributed the 40 out, and you get 40 times 25% plus that 1. So then when you combine these two terms, you get 40 times 1.25. Okay? And so this right here is the efficient method to find the cost of the tax. Okay? Now, bum bum bum, punchline. Don't want to totally cover this up. You'll be able to use this with your justification. Now, if we take looking at what we were looking at here and apply these two efficient ways, I'm not going to use friendly because they're not friendly to me, these two efficient ways to find this information, we can see we have $40. If we add the tax first, we're going to really multiply that by 1.25. And then take the discount, so then we would take that total cost, multiply it by 75%. And that gives us the total. So that's the tax first. Discount first, we would take $40, multiply that by the discounted price of 75%. Then multiply, that gives us that discounted price. Then multiply that discounted price by 1.25, and that gives you the total cost. So we talked about the distributive property, which means that you can essentially pull the same number out. And we talked about the commutative property, which means that you can switch the order in multiplication and in addition. So with that information, do you think that you could make your justification even better than what you already have? And maybe use some more words. Maybe use some properties and explanations of properties. All right, go for it.
Okay, so I guess what we